Father, कैसे?
Alaikum salam. Alaikum salam. Walaikum salam. Yes, 235. In the previous class, we have completed the chemical equilibrium and we have discussed numerical problems based on chemical equilibrium also. Now we are left out with the last topic of your junior inter syllabus, that is called something. What is that something? Let us enjoy that. Suppose, for example, you are talking about a substance AB. Anything, right? Suppose, for example, this AB is added into water. And I am trying to enjoy what are the observations as a science student. For example, suppose, for example, if I am saying, sir, if you are having addition of water Rule number one. Rule number one is saying, sir, I am having addition of that substance, say for example, water. Once you are adding the substance into water, the observation said to me by rule number one, sir, AB remains undissolved in water. This is his observation. And on that basis, I am trying to have some conclusion. What I'll say to him, I have to say that AB remains undissolved in water means, go back to your lower classes teacher, what they taught you, like dissolves like. If suppose AB is not getting dissolved in water, who is water? Water is a polar solvent. Therefore, if AB is remaining undissolved in water, it means to say your conclusion according to your teacher's discussion is, sir, I have to conclude that AB is a non-polar covalent compound. Yes, that is our conclusion number one. Non-polar covalent compound. Fine. Okay. Once you understand this, then naturally you may have a question, sir, what are the possible examples? Non-polar covalent compounds. There are so many examples we can say, for example, C6H6. Benzene is non-polar covalent compound. CCl4 is non-polar covalent compound. Hexane, heptane, so many substances are there, right? However, I am not interested in this one. I am having development of the subject like this. Come on. I asked roll number 2, come on, take a beaker in which you are having water. I am giving you AB. Add that AB in water and tell me your observation. He said, sir, when I am adding AB into water, AB gets dissolved. But retains its molecular state. What is the meaning of that? This means to say the substance is getting dissolved but available as AB units. It is not dissociating into something like A plus and B minus, right? It is retaining as it is, but it is getting dissolved, right? Now, when you are saying that it is getting dissolved, your mind may say, okay, so let us go to that statement that like dissolves like. Right? If it is so, then, sir, this is you are saying AB is getting dissolved. If it is so, it must be a polar compound, right? No, remember, here in this case, we classify this to be as a non-polar covalent compound. Once I say this, then you have a strong objection, sir. How it is possible that whether the statement of teacher is wrong or the statement inverted comma she has told in 9th class, beta, write down that like dissolves like. What about this? We are saying water is polar and this non-polar, and you are saying it is dissolved. Yes, remember, certain non-polar covalent compounds are soluble in water because of hydrogen bonding. Yes, right. Therefore, we can say here they are soluble in water due to availability or due to presence of hydrogen bonding. Due to H bond. Right. And once you are saying so, naturally, who are those fellows? Sucrose, sugar, neutral molecule, it's non-polar molecule, but there is a possibility of OH, right? Because it has OH bonds available, so hydrogen bonding is possible. Sucrose, then naturally you can say glucose, and at the same time you can say, sir, I can talk about fructose, nice. You can say urea, diaminoketone. There are so many examples which are non-polar covalent compounds but soluble in water due to possibility of hydrogen bonding. Fine. Such type of covalent compounds which are non-polar covalent compounds getting dissolved in water due to formation of hydrogen bonding, but they are retaining their molecular state. Such type of compounds in our discussion today are called as non-electrolytes. Yes, they are called non-electrolytes. This is one of the way to understand the concept, right? There is another way I need to require something with respect to my chapter, so I'm going on those lines. What are these substances? They are non-polar covalent compounds, but soluble because of hydrogen bonding, and they are supposed to have possibility of hydrogen bonding, but they're retaining their molecular state. They're not becoming as ion. Nice. I have taken, I asked third roll number. Come on, boy, stand up and take your beaker and add AB in water. He said, okay, sir, no problem. Go ahead. He added AB into water and he observed what he observed. He's saying to me, sir, AB gets dissolved. Okay, nice. AB gets dissolved and undergoes ionization. Okay, right? Now, what is the meaning of this ionization? Go back to your chemical equilibrium. You said calcium carbonate gives you calcium oxide plus water. Dissociation. That was called as dissociation. Then you said, no, no, sir, PCl5 gives you PCl3 plus Cl2. Dissociation. They are called as dissociation, right? But here in this case, there what is the formed? Molecules are formed. Calcium carbonate is a molecule. Calcium oxide is a molecule. Oxygen carbon dioxide is a molecule. Therefore, we have called as dissociation. Hence, we have used one common word, degree of dissociation. Yes. But here in this case, it is also, of course, dissociation. But along with the dissociation, we are having one special thing that is called as formation of ions. Therefore, it is called ionization. Dissociation in this context, supermarket language. Scientific language, yes, ionization, we are having formation of ions. If it is so, right, then such type of substances, who are these fellows? They are supposed to be polar covalent compounds because they are getting dissolved and undergoing ionization. Therefore, here you should say, sir, these are supposed to be polar covalent compounds. When I am saying like this, one boy stand up, he said, no, no, sir, is it not possible to say the word polar covalent compounds are ionic compounds? Yes, ionic compounds do also have this property that whenever sodium chloride is added into water, we are having formation of sodium ion and chloride ion. Therefore, we say ionization process. So any polar covalent compound or ionic compound is considered to be of this behavior, which is having roll number 3. And such type of substances in science are called as electrolytes. Right. Again, I am saying, right, you should have a broad mind understanding. Vision should be large. The word electrolyte and non-electrolyte is based upon conducting ability. Let me enjoy like this, sir. I have taken sodium chloride. I have taken HCl. Who is that fellow HCl? Gas. Now, if suppose, for example, you take HCl gas, is it a conductor of electricity? No. Therefore, we say gaseous form of polar covalent compound is perfect insulator. But when you dissolve HCl in water, aqueous solution of HCl consists of H plus ion and Cl minus ion, and they are carriers of electric energy. Therefore, electrolytes are defined in science as the substances which are insulators in their solid state, in their gaseous state, but they become very good conductors in their molten state or in aqueous solution. For example, go to your kitchen and take dry sodium chloride. Don't do this experiment. Dry sodium chloride and attach one side the phase and one side neutral wire, touch it. You don't have any sensation. Right now, same experiment, you do it, take a beaker, add small sodium chloride, dissolve properly, right, phase wire and the neutral wire and your finger also. Don't do this one. If it is so, you may have a beautiful enjoyment of shock. That is known as mobility of electric current. That is because of ions. They are responsible for carrying electric current. Therefore, electrolytes are defined. I'll define this in second year syllabus electrochemistry. I want here in different style, therefore I have gone. But what is electrolyte? Electrolyte is a substance which conducts electric energy, which conducts electricity in its aqueous solution or in fused state. Solid sodium chloride, bad conductor of electricity. Molten sodium chloride, very good conductor of electricity. Such type of substances are called as Electrolytes. But for me today, my definition goes like this: electrolytes are those compounds which are polar in nature or ionic in nature, and they undergo dissolution as well as ionization. Both the processes takes place. Such type of substances are called electrolytes. Okay, nice. Once you are saying electrolytes, then the question comes, who are these fellows? Electrolytes. Remember, they are all acids. Any acid is electrolyte. No, sir. Bases. Yes, all bases are electrolytes and salts. Remember that any acid, any base, any salt is taken as electrolyte. Once you are saying that we have electrolyte, then till now you may be thinking, sir, Arif Hashmi, sir, where you are going? We have discussion of some chapter, right? Yes, let us come to the beauty of that chapter, how to enjoy that one. For that purpose, what we do, come on, take an acid, base, or an electrolyte. Who is that fellow? AB. Now see what happens. If you are having AB, this AB, if you add water, who is this fellow? Solid. Let us say, for example, sodium chloride. If you take this one along with water, then what happens? It undergoes step number one, which we don't write on the board, which we don't write on the paper in notebook, which we don't write in the examination hall. Examiners also don't write this step. This is called dissolution. What happens? NaCl becomes aqueous NaCl. You cannot separate it. You cannot find it separately. It's a process which takes place. And after that, what happens? Now we have A plus and B minus. Actually, there are two steps here. One step is called dissolution. Second step is called ionization. But what we do, we don't write this one. We say, sir, I have taken AB, sodium chloride, for example, solid. I have added water and then I got it. What? Na plus aqueous and B minus, Cl minus aqueous. This is known as ionization process. Dissolution is prerequisite to have formation of ions, but we ignore that one, right? When time comes, I'll say that is important in one discussion. Okay. Now, if you are saying AB is undergoing ionization, then we have classification here. What is the way of classification? Sir, we are saying that this is dash process, ionization process. If suppose, for example, you are saying the word ionization, right? Then what happens in case of ionization? What is this? Sir, it is conversion of molecule to ionic form. When you say so, then you can extend your understanding. Is it complete or partial? Whenever you are saying ionization, then the question comes to your mind automatically, sir, whether this ionization is complete or is it partial ionization? What do you mean by complete ionization? Sir, AB, I have taken 1 mole of AB and all 1 mole of AB has been converted into ions, A plus and B minus. If it is so, people call this as complete ionization. And such type of substances are called as strong electrolytes. Yes. And when you said the word complete ionization, go back to chemical equilibrium. There you said some word known as degree of dissociation. It is 100%. Practically, if it is 98% also, we accept it to be as 100%. RB people say alpha is equal to 1. If suppose you are having this type of situation, it is called as strong electrolyte. Such type of substances are called as strong electrolytes. Now, what is the meaning of strong electrolyte? Again, the same thing, strong acid, yes, strong base, and all salts. There are 2 salts which usually author says that they are supposed to be weak electrolytes, but basically all the salts are supposed to be strong electrolytes. So therefore, if you are classifying this, then we can say strong acids, strong bases, and salts are classified in the form of strong electrolytes. No, sir. Suppose, for example, if this fellow electrolyte AB is undergoing dissolution, but the problem is it is forming A plus aqueous and B minus aqueous. But when I have given you 100 molecules of AB, I am getting 50A plus, 50B minus. No, sir, I am getting 60 and 60, right? If suppose you are having that type of situation, then you can say this is complete, this is partial ionization. And once you are having partial ionization, then it means to say in this container, we are having AB undissociated, A plus ionized, B minus ionized. That means three species are dancing in the container. On the contrary, left hand side, if you take strong electrolyte, we have only A plus and B minus because it is completely ionized. That means in case of strong electrolytes, we have only ionic form. It is irreversible process. Whereas in case of weak electrolytes, since we are having A plus and B minus and some unionized molecules of AB, if it is so, there is a possibility of forward reaction and backward reaction. That means there is a possibility of reversibility, and wherever you are having reversibility, our mind say there must be equilibrium. Yes, this equilibrium is studied where we have molecules as well as ions. Go back to previous chapter. PCl5 gives you PCl3 plus Cl2 molecules. 2Hi gives you H2 plus I2 molecules. 2NH3 gives you N2 plus 3H2 molecules. In all chemical equilibrium, if you just check out the examples, sir, we have discussed only about molecular species. Yes. Now we are saying that there is a possibility of equilibrium in between molecular and ionic species. Such type of part of physical chemistry where we talk about equilibrium with respect to both molecular species and ionic species, that is known as ionic equilibrium. Yes, ionic equilibrium is that part of physical chemistry which deals with respect to equilibria existing among molecular form and ionic form of species. Both sides we have ions, no problem, possible. One side we have molecule, one side we have ions, possible. Both side molecules, go back to previous chapter known as chemical equilibrium. This is the way with which we discussed. Ionic equilibrium is study of equilibria with respect to molecules and ions and factors affecting it naturally, right? And that is the heading which we have discussed today under this discussion known as ionic equilibrium. Very, very, very important and very long chapter here in this case. Only those students can understand who are having continuation. Rhythm should be understood properly. Otherwise, suppose for example, Ayaram, Gayaram, there is no need of understanding this. Leave it. This is not necessary. If you are sincere, please welcome to the world of ionic equilibrium. Write down as it is available on the screen. Those students, I think there is a gap, therefore you might have forget it. Those students who are coming without a roll number and section, I am removing that one. And one bad habit we have removed, and most of you have learned a good habit saying that we should not write doctor in front of our name. I am removing those doctors also, because we are teaching and we are learning with respect to students. Okay, without name and without section, that is obviously we have to eliminate them. Any doubt if you want to ask, please go ahead. Except saying, repeat once again. Visibility is clear. Very good. What is the problem, Abdul Wajid? What is the problem? Everything is clearly available now. What is the doubt? Tell me. In the last right hand side part, अभी आपका वो मसला हल नहीं हुआ शायद आपको हमेशा वो नेटवर्क का प्रॉब्लम होता बोलते हैं. Yes, 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 I know it. Right? सुधार लीजिए बेटा. कब तक आप नेटवर्क का रोना रोएंगे? If you are having AB, if you are adding in water, right hand side top, I said that it is a completely ionizing, but ionization takes place in two steps. I said first we have dissolution, then we are having ionization, right? And if you are saying that, sir, we don't write that dissolution step, we skip that, but we have to keep in mind, yes, first dissolved, then ionized. Then I have written AB plus water gives you direct step A plus and B minus ionization. Then at the bottom, I said if it is completely ionized, strong electrolyte. If it is not completely ionized, partially ionized, 80%, 40%, 20%, 10%, it is called as a weak electrolyte. Examples of weak electrolytes: weak acids, weak bases. Don't write salt here. Don't write salt. Salts are basically strong electrolytes. I have explained just now the last point only. I have explained better. I explained the last point only. Ionic equilibrium is a study of equilibria with respect to molecules and ions. Is it over? Done. Very good. Wait. Come on. Now, once you understand this, okay, sir, fine, we have no idea why we are unnecessarily creating a new chapter. Chemical equilibrium we have done and we have all the concepts. Why we are going to equilibrium known as ionic equilibrium? Yes, okay. It means to say ionic equilibrium is a study of polar solvents. Wherever we have ions, we have to study that equilibrium. Next point, we are dealing only with respect to aqueous solution. Therefore, in this chapter, pressure will never come to discussion because effect of pressure is appreciable only in case of gaseous state. Therefore, we don't have influence of pressure. Temperature, concentration, yes, they are good friend of us. In this chapter, we don't talk about pressure. Next, whenever we are discussing chemical equilibrium, we have said that there is a requirement of closed container. But remember, 4 marks question for doctors that always closed container is not necessary. The word closed container, it means to say that we are having discussion with respect to gaseous substances. Calcium carbonate gives you calcium oxide plus carbon dioxide. Yes. But suppose, for example, if someone is enjoying the concept of equilibrium of ice and water, water will not fly up, ice will not fly up. In such cases, there is no discussion at all with respect to closed containers. Therefore, if someone asks you equilibrium processes are attained only in case of closed containers, no, it's wrong. It's wrong. It's possible in case of open container, but you should have no gas phase. And in this chapter, ionic equilibrium, we discussed only with respect to solution phase, aqueous solutions and non-aqueous solutions. Therefore, there is no requirement of closed container. The next one, yes, whenever we are discussing ionic equilibrium, one of our dearest friend is water, right? You can also take the polar solvents, but we take Mr. Water to be as universal solvent, and we every time enjoy with water to have ionization process. Without that, we cannot study ionic equilibrium chapter. Okay, got it. Once you got, then you are saying, sir, there are electrolytes, strong electrolytes. You are saying strong acids, strong bases and salts. Weak electrolytes, you are saying weak acid and weak base. But to our mind, the question comes, who is an acid? Yes. The next question in our mind is, as a student should come, who is an acid, who is a base, and who is supposed to be the salt. For that purpose, let us go back and enjoy with our teacher that she told Arrhenius theory of acids and bases, right? She's told one more theory called as Bronsted theory of acids and bases. She also said about Lewis theory of acids and bases. We'll simply try to revise all the concept, and we give honor to our teacher and say, okay, come on, Arrhenius theory of acids and bases. How to proceed? For that purpose, let us start that. What is the discussion? Theories of acids and bases. Doctors, very important. Scientists, no problem, go ahead. Fine. No, first one. Arrhenius theory of acids and bases. What our teacher told you, she said, a substance AH, say for example, when added into water, if it releases H plus ion, then it is called as Arrhenius acid. That means Arrhenius acid is a substance which, when added in water, gives you H plus ion. It is called Arrhenius acid. No, sir, I am having a substance, say for example, BOH. If it is added into water, what happens? It should give you OH minus ion. That means a substance which releases H plus ion in presence of water, a substance which releases OH minus ion in presence of water is called Arrhenius acid, Arrhenius base, right? This is supposed to be Arrhenius acid, and this is Arrhenius base, right? Okay. First point. See how the theories to be discussed and studied at your home when you are doing homework. First point, definition. First point, definition. Over. Second point, examples, right? All those substances which contains hydrogen, they are supposed to be acids. No, statement is not completely correct. All those substances which contains hydrogen and they should have tendency to release hydrogen, they are called Arrhenius acid, right? A substance which when added to water, if it is giving you OH minus ion, if it is releasing OH minus ion, it is called Arrhenius base. So availability is not the criteria, releasing is the criteria. If it is releasing H plus ion, go ahead, right? Therefore, people say HCl, H2SO4, all those type of substances. Therefore, I use the word protonic, containing proton, protonic acids. HCl, HNO3, H2SO4, HF, HI, so many are there. You people are genius. Protonic acids, these are the substances which can release H plus ion. Similarly, if you want to talk about bases, what about them? Metal hydroxide. Achha, before going to the protonic acids, then here we have classification as a, say for example, sir, I am having two types of acids. 10th class definition I am saying. What is said to be called mineral acids. Inorganic acids, some people say, but correct name is mineral acids. For example, HCl, H2SO4, HNO3, H3PO4, so many fellows are available. All these are supposed to be dash, right? HI, and who is that fellow? Perchloric acid, HClO4. Strongest of all acid is called perchloric acid. These are called mineral acids. Then we have organic acids. Because of this reason, author says inorganic acid. This is inorganic or mineral acid. Any acid which consists of carboxylic acid group, right? If you are having this one, they are called as Arrhenius acids, right? For example, formic acid, acetic acid, ethanoic acid, propanoic acid, so many are there. CH3COOH and dibasic acid, oxalic acid, yes, all carboxylic acid compounds, they are supposed to be organic acids, right? That means they have tendency to release H plus ion. Any substance which gives OH minus ion, they are called as bases, Arrhenius bases. Who are those fellows? Metal hydroxides. Metal hydroxides. For example, the metals of first A group elements, second group elements, transition metals, anything we can take, right? You can write like this. You are genius, therefore you can write, sir, it's enough, right? Monobasic, dibasic, tribasic, depending upon the valency factor. All these are supposed to be Arrhenius bases. Very good. Next. Third point, strength of the acids and bases. How do you define to be as who is said to be stronger acid and who is weaker acid? Nothing, sir. Very simple. Strength of an acid depends upon tendency to release H plus ion, tendency to release OH minus ion, not availability of H plus or OH minus ion. If suppose, for example, you are having H plus ion in the acid, more number of H plus ion, it is strong acid. No, no. Not number. See, acetic acid, we are having so many hydrogens. It is a weak acid. HCl, poor fellow, one hydrogen, but strong acid, right? That means number of hydrogens is not criteria. Tendency to release H plus ion, degree of dissociation should be more. Therefore, strength of an acid or base. Wait. Of acid or base depends upon relative tendency to release H plus ion. As the tendency of releasing H plus ion is more, the acid becomes stronger and stronger. Nice. Fourth point. neutralization. What is the meaning of neutralization? According to Arrhenius theory, H plus ion of the acid do combine with OH minus ion of base to form salt and water. That is called neutralization. Therefore, according to this theory, neutralization is a process in which Arrhenius acid AH do combines with Arrhenius base VOH to form dash salt and water AB and dash. Formation of salt and water is the criteria for neutralization of Arrhenius theory. Finished. Over. First definition, next example, third what we can say strength, and next neutralization. Now the last and fair ball. What are the limitations? Before going to limitation, what are the advantages? Simplest first attempt in the universe to understand who is an acid, who is a base. Because before Arrhenius, people used to classify acids and bases depending upon their taste. And nowadays, in science, tasting and saying something is a crime. We cannot go because there are so many poisonous substances. Therefore, Arrhenius was the first person to classify in a scientific manner, right? Releasing H plus ion, releasing OH minus ion, like that. Okay. Now, what are the limitations? There are some limitations available, of course, because it is first attempt, right? The limitations are number one, not applicable for non-aqueous solvent. Yes, for example, roll number one is saying, sir, what is HCl name? Hydrochloric acid. Acid name itself is acid. Take that HCl and add in benzene container. Nothing will happen. No H plus ion is released. That means the definition of Arrhenius theory is restricted with respect to aqueous system only. It is not applicable in case of non-aqueous system. Nice. Next, he suggested that whenever a substance is added into water, it releases H plus ion. This is wrong. There is no release of H plus ion because H plus ion never exists. Right? Once you are saying that AH is releasing H plus ion, right, in presence of water, remember this H plus ion may combine with water so as to have formation of hydronium ion. Sometimes it will go even with 4 water molecules so as to give you H9O4 plus. And what is this? It is supposed to be hydrated form, right? And here in this case we have H5O. What is that? 3 plus. These are all called existence of H plus ion, but most commonly we insist upon hydronium ion. Actually, he should have said like this, that acid is that substance which when added into water releases hydronium ion. He said H plus ion. Availability of H plus ion or presence of free H plus ion is a wrong thing. It is not correct statement. Next. Suppose, for example, you are saying, sir, I am having any other limitation. Yes, remember that in general, when you talk about substances, if it is having H plus ion, it is not necessary that it should be an acid. For example, methane, right? We don't consider it to be as releasing H plus ion with a strong tendency. There are so many substances, right? Rather than you can consider this fellow, ammonia. It has hydrogen, right? So if you discuss the concept of Arrhenius, here in this case. Next, right? Remember that all metal oxide, general property, all metal oxides are basic in nature. And all non-metal oxides, not necessary, sometimes they are supposed to be amphoteric also. Generally, they are dash, acidic in nature. But for example, here metal oxide, magnesium oxide, calcium oxide, zinc oxide, etc. They are basic. Where is the OH minus ion? There is no OH minus ion, right? Non-metal oxides, for example, sodium, nitrogen pentoxide, carbon dioxide, sulfur trioxide, all they are acidic in nature, but there is no H plus ion to release. Therefore, Arrhenius theory is not applicable in case of metal oxides to explain basic nature and non-metal oxide to be explained as acidic nature. Basic nature of metal oxide, acidic nature of non-metal oxide cannot be explained. Okay. Now, once you're having limitation, naturally we should think about some other aspect. That aspect we'll discuss in the next class. Take down that. Read that. Read that. There is no explanation required for first point. Read that point. Not applicable for non-aqueous solvent. Finished. Understand? Think over it. Think. What is the meaning of aqueous? What is the meaning of non-aqueous? What is the definition of Arrhenius acid? A substance which, when dissolved in water, gives H plus ion. H3O plus is called hydronium ion. Hydronium. The other two are not having name. They are called hydrated H plus. Proton. Yes, you are right. Two oxygens, four oxygens. Is it over? Okay, go ahead. Go ahead, right now. Fine. Those who have finished, have a quick look on that. If you have any doubt to ask, welcome. Point C. Ammonia is having basic nature. Ammonia is supposed to be basic in nature, right? But according to Arrhenius theory, base should be having OH minus ion. It is not having OH minus ion here. Therefore, we can say the basic nature of ammonia cannot be explained. The drawback is basic nature of ammonia cannot be explained. It is having hydrogen, therefore it must be an acid. Over. Yes, fine. That will stop here. Remaining discussion will continue in the next class. Thank you. Assalamu alaikum.